Hello students, this is Mrs. Raposa, and this lesson is taken from section 1.4 of our book titled Measure and Classify Angles. In this video lesson, we're going to focus specifically on measuring angles using the angle addition postulate. Please have a copy of the 1.4 Measure and Classify Angles notes in front of you, blank copy, and please fill in the examples as you're watching the video. And as always, you know you can always pause the video and replay it if there's something that you didn't catch. Let's get started. For example 1, we're just asked to name the congruent angles based on the markings we see in the diagrams. Remember that congruent angles are angles that have the same measurement. Angle ABH is this angle right here, ABH. And it has two tick marks, or two arches drawn in it. And the other angle that has the same marking is over here, and that is angle EDF. I could call it angle FDE also. The only important thing is that when I name it with two letters, that the middle letter D is the vertex where the two segments intersect. So let's now find what angle is congruent to angle BCD. That angle has one arch. I also notice that this angle has one arch. That's angle CBD. I could also call it angle DBC, just as long as the middle letter is the vertex of the angle. I'll choose to call it angle DBC. Well, that is also congruent to the other angle with one arch, and that is angle CDB, or I could call it angle BDC, just as long as the middle letter is the intersection of the two segments, the vertex. Lastly, let's find out what angle is congruent to angle CDE. And that angle is right here. And that angle has one arch with a line through it. Well, that's the same marking that's over here. And that's for angle HBG. Or I could call it angle GBH. And that's how you name the congruent angles in a diagram. Just look at the marks. The angle addition postulate tells us that if we have a point P on the interior of some angle, like RST, then we can make a ray through S and P, and that divides this angle into two angles. And to find the measure of angle RST, we simply add the measure of angle RSP, whatever that angle measure is, to the measure of angle PST. So we'll use the angle addition postulate for example 2. In this diagram, we are told that the measure of angle RSP is equal to 34 degrees. So I'll mark that angle as a 34-degree angle. We're also told that the measure of angle TSP is equal to 48 degrees. So I'll mark that as a 48-degree angle. Well, that means that the measure of angle RST is going to equal the sum of those two angle measures, 34 plus 48 degrees, which will give me 82 degrees. For example 3, we're told that the measure of angle LKN is a 145-degree angle. Angle LKN is the large angle. Using the angle addition postulate, I know that the measure of this angle LKM plus the measure of angle MKN are going to add to the measure of angle LKN, which is 145 degrees. Replace this measurement LKM with its variable expression 2x plus 10 and add it to the variable expression for the measure of angle MKN, which is 4x minus 3, and we get this equation. 145 degrees is equal to 2x plus 10 degrees plus 4x minus 3 degrees. Collect like terms on the right side. 2x plus 4x is 6x. Positive 10 and negative 3 add to 7, and we get 145 equals 6x plus 7. Subtract 7 from each side to get 138 equals 6x. Next, divide each side of the equation by 6, and we get 23 equals x. If 23 is equal to x, we can now find the measure of angle LKM, and the measure of angle MKN. The measure of angle LKM is 2x plus 10, but x is 23. So replace the x with 23, and we get that it is 56 degrees. So the measure of angle LKM is 56 degrees. To find the measure of angle MKN, I know that that's 4x minus 3 degrees. Substitute 23 in for x, and we get that the measure of angle MKN is 89 degrees. Always check your answers. So to check your answers, we're going to add the 56 and the 89 degree angle together to make sure that they do add up to 145 degrees, and they do. It checks. For example 4, I am told that the angle ABC is a straight angle. That's this right here. It's a straight line. So the measure of angle ABC is 180 degrees. We're also told that the measure of angle ABD is x plus 25, so I'll mark my diagram. We're also told that the measure of angle DBC is 2x plus 5, so I'll mark my diagram with that angle measure. Well, using the angle addition postulate, I know that the sum of these two angles has to add up to 180 degrees. Get rid of the parentheses since everything is being added, and then collect like terms. X plus 2x is 3x, 25 plus 5 is 30, and I get 3x plus 30 equals 180. Subtract 30 from each side of the equation to get 3x equals 150. Lastly, divide each side of the equation by 3 to get x equals 50. Well, if x equals 50, I can now answer the question which was to find the measure of angle ABD and the measure of angle DBC. Well, if x is 50, the measure of angle ABD is x plus 25, then that angle is 50 plus 25, which is 75 degrees. So angle ABD measures 75 degrees. To find the measure of angle DBC, which is 2x plus 5, substitute 50 in for x, and I get that that angle measure is 100 plus 5 degrees, which is 105 degrees. So angle DBC measures 105 degrees. Always check your answer to make sure it makes sense when you're done. Those two should add up to 180 degrees, and they do, so we have the correct answer. For example 5, we are told that ray YW, right here, bisects angle XYC. The word bisects means that it divides that angle into two congruent angles. We're also told that the measure of angle XYW is 18 degrees. That must mean that the angle WYZ is also 18 degrees. So, to find the measure of angle XYZ, I simply add 18 degrees to itself to get 36 degrees. For example 6, I am told that ray OB, the red one, bisects angle AOC. That means that these two angles have the same measurement because this is an angle bisector. We're also told that the measure of angle AOB is 4x plus 4 degrees, and that the measure of angle BOC is 6x minus 11 degrees. Well, remember that those two angles are congruent. That means that their measures are equal to one another. So if those two angles have equal measures, that means that 4x plus 4 has to equal 6x minus 11. To solve the equation, I like to subtract the smaller x variable term from the larger to get a positive 2x minus 11 on this side is equal to 4 on this side. Next, I'm going to add 11 to each side of the equation to get 15 equals 2x. When I divide each side of the equation by 2, I get x equals 7.5. Well, if x equals 7.5, now I can answer the question, what is the measure of angle AOB and the measure of angle AOC? Well, the measure of angle AOB, they told us, was 4x plus 4. So I'm going to substitute 7.5 in for x to get 4 times 7.5 plus 4 degrees, which is going to give me 34 degrees. So the measure of angle AOB is 34 degrees. Well, since these have the same measure, I can just say, well, this is also a 34-degree angle, and the measure of angle AOC will just simply be 2 times 34 degrees, which is 68 degrees, and I could say I was done, but I always like to check my work. To check my work, I'm going to make sure that when I replace this x here with 7.5, that I also get BOC. Angle BOC is 34 degrees. So the measure of angle BOC is 6x minus 11. Substitute 7.5 in for x, and I'll also get that that is a 34-degree angle. So yes, it does check. For example 7, we also have an angle bisector. KM bisects angle LKJ. But this one's a little different. In this one, we are told that the measure of angle JKL, which is the big angle, is 12x plus 5 degrees. So we're not given one of the smaller ones. We're given the entire angle measure as a variable expression, 12x plus 5 degrees. We're also told that the measure of angle MKL is 5. MKL is 5x plus 9 degrees, so I'll mark my diagram. Well, since this is an angle bisector, I know that this angle measure, MKJ, is also 5x plus 9 degrees. So using the angle addition postulate, I can say that the sum of these two angle measures added together has to equal the measure of the larger angle, 12x plus 5. Combine like terms on the left side of the equation to get 10x plus 18 equals 12x plus 5. Next, subtract the smaller x term variable from the larger to get 18 equals 2x plus 5. Next, subtract 5 from each side of the equation to get 13 equals 2x. Lastly, divide each side of the equation by 2 to get that x equals 6.5. Now that I know x equals 6.5, I can answer the question. The measure of angle MKJ is 5x plus 9. Substitute 6.5 in for x, and I get that the measure of that angle is 41.5 degrees. So the measure of angle MKJ is 41.5 degrees. So now I know that this angle measure should also be 41.5 degrees. I can do it a quick, easy way, and that would mean that the measure of angle LKJ would be 2 times 41.5 degrees, which is 83 degrees. But I always like to check my work, because when I plug 6.5 in for x here, I should also get that this whole angle is 83 degrees. So the measure of angle LKJ is 12x plus 5. Replace the x with 6.5, and I get that that angle measure is 83 degrees. So we did get it correct. And to leave you with a little joke, because the weather is getting colder, if you ever get cold, just stand in a corner for a bit, because it's always about 90 degrees in the corner. Have a great day, guys.